How do we toss coins using a computer? We will do that by generating Bernoulli random numbers. A Bernoulli random number can take the value 1 with probability p, and that we're going to associate with heads, or the value 0 with probability 1 minus p, and that we're going to assign to tails. To generate random numbers from the Bernoulli distribution, we're going to use the following construction. Take the 0-1 interval and divide it into two subintervals. The first subinterval is between 0 and p, and it has length p. The second subinterval goes from p to 1, and it has length 1 minus p. We're now going to sample uniformly the 0-1 interval, and if the sample falls here, we're going to assign it the value 1, and if the sample falls here, we're going to assign it the value 0. Since the sample is uniform, the probability of obtaining a 1 is proportional to the length of this subinterval, which is p. And the probability from obtaining a 0 that is generated in a sample here will be proportional to 1 minus p, which is the length of this subinterval. We're going to summarize this in a pseudocode. So here we're going to generate samples from a Bernoulli distribution with parameter p. First, we generate a uniform 0-1 sample. Then we're going to compare that sample with p, and if it is smaller than p, we're going to give it a value 1. Otherwise, we're going to give it a value 0. And here is how the code looks like. In this demo, we're going to generate Bernoulli random numbers with a probability of 0.8. This corresponds to a coin whose probability of obtaining heads is going to be larger than the probability of getting tails. For heads, we'll have a probability of 0.8. For tails, we'll have a probability of 0.2. In this code, we're generating a matrix with 50 rows and 10 columns. The first thing we do is to simulate uniform 0-1 random numbers. Each of these numbers is compared to p. If the value of the uniform 0-1 random number is smaller than p, which in this case is 0.8, we'll generate a 1. Otherwise, we'll generate a 0. We will now compare to the histogram, and here we're calculating the fraction of zeros that we have generated, and here the fraction of ones. And this is the result. As you can see, basically the sample, which is this bar in blue, is very close to the theoretical value that we expected. So the fraction of random numbers that we have generated whose value is 1 is approximately 0.8, and the fraction of random numbers that we've generated with value 0 is approximately 0.2.